Now from this problem, we find that we have to calculate the divergence of vector field at this point. So the first point, that is divergence, can be written as this. Second thing, in which coordinate we are talking about should be clear. So that can be confirmed from the point. It can be confirmed from here as well, but the simplest way is to find from here. It is distance, angle and angle. That is possible in the case of spherical coordinate system. So r, theta and phi. So in that case, try to find the first right general formula here. 1 by h1, h2, h3 we have written already. So just on the basis of that, we will write the final equation. So 1 by h1, h2, h3 del r h2, h3 and component of v in the direction of r. So that is, okay, just write VR plus theta h1 and h3 in the direction of theta plus phi h1 h2 in the direction of phi. So this is the general form for divergence of any vector field. Now this will be a scalar quantity. Now simplify this based on this statement. h1, h2, h3 will be, we know, 1 r and r sine theta was there. So it will be 1 by r square sine theta h1, h2, h3. I am writing this from the previous table that is formed for u, v, w and h1, h2, h3 in different coordinate system, and in cylindrical coordinate, spherical coordinate system it was 1, h1 was 1, h2 was r and h3 was r sine theta. So on the basis of that, h1, h2, h3 multiplied and written here r square sine theta, and h2, h3 can be r square sine theta, and vr is 2r cos theta cos phi derivative with respect to r. This is the component of v in the direction of ar. This is the multiplying factor that is set for the spherical coordinate system in case of divergence. The second one, del over del theta, h1 is 1 and h3 is r sine theta. So here we can say r sine theta multiplied with v theta. V theta component is 0 here, phi component and ar component is there. So we will multiply from 0. This will be like that. Plus del phi, and in that case h1, h2 will be there. h1 is 1 and h2 is r. A phi will be r half. Hope it should be okay. Now differentiate and find the final value. 1 by r square sine theta. This will give you 2r cube. If you will do partial derivative, then it will give you 6r square, and remaining remaining terms will be here sin theta, cos theta, cos phi. Okay, plus 0 plus r 3 by 2, and differentiation with respect to phi will give you 0 because this is partial derivative. So it will be also 0. Now simplify this. R square will be cancelled out. Sin theta will be cancelled out. The remaining terms will be 6. Cos theta is 30. That is root 3 by 2. Cos phi is 60. That is half. You can simplify as 3 root 3 by 2. This is your final answer. So if you will find the divergence of vector field V at this point, then the divergence will be 3 root 3 by 2. Now the next problem. A vector field is given as V. Find the value of C for which the field is solenoid or divergence-less. So as meaning suggests, if it is asked divergence-less, it means divergence of field should be 0, or it is asked, if it is asked the field is solenoid, in that case divergence is also 0. So in both the cases you have to prove that the divergence of vector field is 0. And if it is already said that divergence of field is 0, then the another unknown parameter you have to find. So for this question they said find the value of C in this, so that I don't know, C, find the value of C so that this vector becomes solenoidal. So let us start, and before starting, the first thing that I have to decide is divergence should be del dot V, and it is divergence less, so it should be 0, first thing. Second point, in which coordinate we are talking about must be clear. So from here it is confirmed that we are talking about rectangular coordinate system. So it becomes easier for everyone. In rectangular coordinate system, we know it can be written as del over del x Vx del over del y Vy plus del over del z Vz. Sorry, Vz. Now simplify this. Vx is this. Vx is this. Do partial derivative with respect to x. It will give you 1 plus 0. Yes, 1 plus 0 plus. Do partial derivative of this with respect to y. You will get derivative of this with respect to y 0. Derivative of this with respect to y will give you 0. Will get you 0. Now derivative of this with respect to z. How much you can get? I think there is something missing. Okay, consider z here. Now there will be no problem. Okay, partial derivative of this with respect to z will give you minus c. Okay. Now according to the observation, it should give you 1 minus c should be equal to 0, implies that c is equal to 1. So this is your final answer. To make this vector field, if I made these changes, to make this vector field divergence less, or you can say to make this vector field solenoidal, the value of c should be equal to 1. So the important point was here, if in the exam, most probably in the GATE exams, if it is asked the field is solenoid, it means you have to find the divergence is equal to 0. Now next question is related to curl, and the problem is curl of vector field V at any point we have to find. So from the previous study, we know that the first thing, curl of any vector field can be written as the cross product of vector field with del operator. Okay, and it is equal to the general formula we know, 1 by h1 h2 h3 and h1 in the direction of unit vector in the coordinate and so on. So we will write that later. The first thing, curl of field is given here. So field is V. Second thing, in which coordinate we are talking about, that is confirmed from here, rho, phi, z. So we are talking about cylindrical coordinate system. So in cylindrical coordinate system, the curl will be 1 by h1, h2, h3. h1 is 1, h2 is rho, h3 is again 1 here. Okay. So here will be h1, 1 a rho. So 1 by rho, h1 a rho, h2 a phi, h3 a z, del over del rho, del over del phi, del over del z. The third one, here it is h1, the component of vector field in the direction of arrow. So h1 is 1, it will be rho z sine phi. h1 here, it should be h2, the component of v in the direction of phi. h2 is rho, in the direction of phi it will be 3 rho z square cos phi. Okay. Now the third one, h3, that is 1, the component of this in the direction of z, that is 0. Now it is simple and we can find, this is determinant, not the matrix. Now solve it. It will give you 1 by rho, this a rho times 0 minus with respect to z. So it will be 3 rho square, with respect to z it should be 2z cos phi, if I am right. Okay. And the second is minus rho a phi. We know how to find the determinant, that is the grade 12 mathematics. So minus rho a phi, this 0 minus this, this will be rho sin phi plus this az times this, that will be 3 rho square, differentiation with respect to rho, it will give you 6 rho z square cos phi minus rho z sin phi, differentiation will be cos phi. Hope it is clear to everyone. Now put the value of rho, phi and z. This is in the direction of z. Okay, 1 by rho, it will give you minus 6 25 6 into 25 cos phi is 0, finished, no need to worry about that. So a phi, a rho 0 minus sin phi 90, rho is 5, so minus 5, it will be plus 25 a phi. And here 0 0, no need to worry about az. Okay, the final answer will be 25 by 5, that is 5 a5. Okay, then the curl of vector field V is 5 a5. It means the field has capability to curl at this point, around this point, with the strength this in the direction of phi. Now let us do next problem, which is given as vector field V is given as this. Find the value of k where the vector field V is irrotational. So here two things should be very clear. First thing, in which coordinate we are working. Second thing, what is the meaning of irrotational? Irrotational, so let us start from this one. If it is irrotational, it means the field does not have any capability to rotate around any point. So it means curl of this vector field will be 0. So in the previous case we have seen that the divergence was 0. Here we will, because in that case it was solenoidal, that was named divergenceless. It is irrotational, that is curl of V should be equal to 0. First thing. Second thing, in which coordinate we are talking about, that is clear from here. So that is very simple now. We have to make the curl of V should be equal to 0, and we know, as we have done in the previous case, in case of rectangular, it is so simple. Ax, because h1, h2, h3 is 1, so no need to worry about those too much. Ax, ay and az, del x, del y and del z. H1 component of V in the direction of x. So H1 is 1. The component of V is z cos xz plus y. Now the component in this direction and the component in this direction. So it will give you the curl of vector field V. Okay, as it is said, it is irrotational, so it should be equal to 0. Now try to complete it. Ax, this. The derivation of this with respect to y will give you 0, minus the derivation of this with respect to z will give you 0. Now this is 0, and if you will differentiate with respect to x, this with respect to z, both will give you same result, and the differentiation of this with respect to z will give you 0. So same minus same will give you 0. So 0 minus 0 here, the remaining term will be plus az 2k minus 1 should be equal to 0. So it is possible only when 2k minus 1 equal to 0 and k is equal to half. So the value of k as half makes this vector field irrotational. Now the next question is, a scalar field A will be harmonic at all points for what value of k? So the field is scalar, and if any scalar field is harmonic, then in that case the Laplacian of that field will give you 0. This should be clear to all of you. So in this case we have to find just Laplacian of this scalar field A, and we know this is double derivative. It can be further written as del dot del A. So don't worry about this, just you know the final formula. So just write, this is in cylindrical coordinate system, sorry, this is in rectangular coordinate system, so that is the simplest one. Del square A divided by del x square plus del square y, del square A del y square, del square A del z square, and as it is harmonic, in that case it will give you 0. Now double derivative of this with respect to x will give you 2xy. Okay, put the value of a, del square del x square 1 plus 2k x square y plus xy z plus del square or del y square 1 plus 2k x square y plus xy z plus del square del z square will give you 0. Now differentiate it, 2xy, again you will get 2y, 2y 1 plus 2k, it will give you yz. Further, if you will derive it, differentiate it, then it will give you 0. Plus, with respect to y, first derivative with respect to y will give you this quantity, second derivative will give you 0, and this will be 0 in second derivative, and in this one first derivative will give you 0, first derivative will give you this one in this case, and second derivative of this will give you 0. So after all, this will be equal to 0. And in that case, 1 plus 2k will give you 0 only when k will be equal to minus half. So to make this scalar field A harmonic at all points, the value of k should be equal to minus half. And this is the end of the coordinate system and differential operator. Thank you very much.